Okay. Welcome to Mathematics Online Lecture Series by Professor K. Narasimhan. Wait few minutes for joining the others. Okay, today we will start with a new topic, beta gamma functions. Now this is another very important concept. We have several applications in engineering, so it is useful for engineering applications. Okay, today we will discuss about beta gamma functions. So beta gamma functions, first we define the beta gamma functions, then properties of beta gamma functions, then we will discuss about the few problems or few applications based on beta gamma functions. Finally, we will apply the beta gamma functions. And also we will discuss few relations between beta and gamma functions. Okay? Now, what is the definition of beta function? First we will discuss about beta function. Beta function. Beta function. So beta function is a function of two variables, like our routine functions. Suppose if you take a function of two variables, if you take a function f of x, y, it is a function of two variables like x square plus y square by x plus y, like that. This is also a function of two variables. This is also a function of two variables, beta mn, but it is defined on a definite integral. So previously all these functions are based on algebraic expressions, but this is defined on definite integral. Integral 0 to 1 x power m minus 1 into 1 minus x whole power m minus 1 dx. Now, and also if you observe two unknown variables m and n, both are positive. So beta is a function defined on two variables m and n. Now what is the function? Integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx. Okay. Now, suppose if you evaluate this integral, you will get some expression in terms of m comma n. So this is the definition of beta function. Beta function, beta mn equals integral 0 to 1 x power m minus 1 into 1 minus x whole power m minus 1 dx, where m and n are positive. Okay. Now, gamma function. Gamma function. This is also a function of one variable only. The beta function is a function of two variables, but it is a function of one variable. Now this is capital gamma. gamma n equals to integral 0 to infinity e power minus x into x power n minus 1 dx where n is positive. Okay. Now observe, this is also a function of one variable. This is a function of one variable. Beta function is a function of two variables. Now gamma n equals to capital gamma n equals to integral 0 to infinity e power minus x into x power n minus 1 dx where n is positive. Okay, fine. Now if you evaluate this integral, you will get some expression in terms of n. Such function is called gamma function. So here we discussed two definitions of beta and gamma functions, beta function and gamma function. Beta mn equals to integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx. Gamma n equals to integral 0 to infinity e power minus x into x power n minus 1 dx where n is positive. So now we will create some wonders using these two definitions, beta and gamma functions. So what are the wonders? One by one. First we will discuss about the properties of beta function and also properties of gamma function. Then we will discuss few problems based on beta and gamma function. Finally we will discuss about relation between both the functions. Finally we will apply the beta and gamma functions. Now properties of beta function. First we will discuss about properties of beta function. Properties of beta function. Actually we have only one property, that is nothing but symmetrical property. What is the symmetrical property? Beta mn equals to beta nm. So in this definition, if you interchange m and n, you will get the same function. That is a property. This property is called symmetrical property of beta function. What is beta function? The symmetrical property beta mn equals to beta nm. If you interchange m and n, you will get the same function. Now we will prove this property. Now what is the procedure? By the definition of beta function, by the definition of beta function, what is the definition? Beta mn equals to integral 0 to 1 x power m minus 1 into 1 minus x whole power m minus 1 dx. Okay. Now this is 1. So in this integral, suppose if you put x equals to 1 minus y, what happens? If you put x equals to 1 minus y, dx becomes dx equals to minus dy. Suppose if you substitute all these two things in beta function, beta mn equals to integral x is 1 minus y, 1 minus y whole power m minus 1 into 1 minus 1 minus y. I will write here 1 minus x is nothing but 1 minus 1 minus y. 1 minus 1 plus y is nothing but y. This term is nothing but y power m minus 1. Dx becomes minus dy. And also, if you put x equals to 0, then what happens? If you put x equals to 0 in this expression, 0 equals to 1 minus y and y equals to 1. So, lower limit is 1. If you put x equals to 1, 1 minus 1 both are cancelled, y becomes 0. Now this is negative sign and interchange the two limits. Integral 0 to 1 y power n minus 1 into 1 minus y whole power n minus 1 Indefinite integrals, if it is y or x, you will get the same value, the same function or same expression. Then what happened? Left hand side is beta mn. Left hand side is beta mn. Right hand side. Compare with equation 1. If you compare with equation 1, integral 0 to 1, integral 0 to 1, here x power n minus 1, here x or y both are same here, n minus 1. Okay, here m, here n, here n, here n. So what happened? I will rewrite the expression, then we will write the expression. X power m minus 1, 1 minus x whole power m minus 1 dx. For understanding, if you put x equals to y, dy becomes dx. You will get this expression. This is nothing but beta m. Now what is left hand side? Beta m. Now finally we got beta mn equals to beta nm. Symmetrical property of beta function. Very simple. The key part is this one. If you put x equals to 1 minus 5, you will get this proof. Very simple concept. I will repeat again. Symmetrical property of beta function. Beta mn equals to beta nm. Now we will prove this property. By the definition of beta function is beta mn equals to integral 0 to 1 x power n minus 1 into 1 minus x whole power n minus 1 dx. If you put x equals to 1 minus y, dx becomes minus of dy. If you substitute all these two things in equation 1, left hand side is n, integral x becomes 1 minus y, 1 minus y whole power n minus 1, 1 minus x, 1 minus x is 1 minus y, already we discussed 1 minus of minus y is nothing but y power n minus 1, dx is minus dy. Now limits, if you put x equals to 0, y becomes 1. If you put x equals to 1, y becomes 0. Okay, now here negative sign, interchange the two limits, integral 0 to 1, y power n minus 1 into 1 minus y whole power n minus 1 dy. Now, for our understanding, if you put x equals to y, what happened? Y equals to x. Y equals to x, what happened? Dy becomes dx. You will get the similar expression, integral 0 to 1, x power n minus 1 into 1 minus x whole power m minus 1 dx. Now this is 1. From 1 and 2, compare 1 and 2, what happened? Integral 0 to 1, x power n minus 1, in the second equation, right hand side is n minus 1. Here 1 minus x whole power n minus 1, that one is m minus 1. Okay, just copy this one, I will come back 1 minute.
అవుతుంది సార్ అవుతుంది మేడం
Okay. So if you observe right hand sides of equation 1 and 2, so m in place of m you will get n, in place of n you will get m. That's why interchange these two. This expression is same as beta mn. Beta mn equals to beta and m. Now we will discuss about another question, another properties of gamma function. Second property, gamma 1 equals to 1. Now second property and also first property of gamma function, gamma 1 equals to 1. Now proof of that. By the definition of gamma function, gamma n equals to integral 0 to 1, 0 to infinity, e power minus x into x power n minus 1. Now by the definition of gamma function, gamma n equals integral 0 to infinity, e power minus x power n minus 1 dx. Now we will prove gamma 1 equals to 1. Gamma 1 is nothing but gamma of 1, n equals to 1. If you put n equals to 1, what happens? Gamma 1 equals to integral 0 to infinity, e power minus x into x power 1 minus 1 e x power 0 dx. Integral 0 to infinity, e power minus x into dx. Now integral e power minus x is minus of e power minus x, integral 0 to infinity. Okay, I will write here. Now put it, x equals to infinity, e power minus infinity, minus or minus plus, if you put x equals to 0, minus or minus plus 1, e power minus infinity is 0, 0 plus 1 equals to 1. Finally, you will get gamma 1 equals to 1. I will repeat again. Second property, gamma 1 equals to 1. Now we will prove this one. By the definition of gamma function, gamma n equals to integral 0 to infinity, e power minus x into x power n minus 1 into dx. Okay. Put n equals to 1. N equals to 1. 1 minus 1 0, x power 0. X power 0 is 1. Integral 0 to infinity, e power minus x dx. E power minus integral e power minus x is minus of e power minus x. Integral 0 to infinity. Put x equals to infinity, minus of e power minus infinity. So for substituting the second and minus or minus plus e power 0 is 1. So this value is 0, this value is 1, 0 plus 1 is 1. Now this is gamma 1 equals to 1. Now this is the second property. Just copy the solution. Okay. Now next property. Now third property, gamma n plus 1 equals to n into gamma n. So now we will prove this result. Already we applied the same formula in Laplace transforms. Okay. Now what is the property? Gamma n plus 1 equals to n into gamma n. Now we will prove this result. By the definition of gamma function, by the definition of gamma function, gamma n equals to, by the definition of gamma function, gamma n equals to integral 0 to infinity e power minus x into x power n minus 1 dx. Okay. Now we will integrate. This is using UV formula. What is integral u? U into integral v minus integral of derivative of u into integral v. Using this formula, we will integrate. U is e power minus x. First, e power minus x into integral integral x power n minus 1. X power n minus 1 integral value is n minus 1 plus 1 by n minus 1 plus 1. Okay. Limit 0 to infinity minus integral 0 to infinity. Okay, fine. Put derivative of u is minus e power minus x. Okay. And also integral v is already known, x power n by n dx. Okay, I will write here. If you put x equals to infinity, e power minus infinity is 0. Okay. Suppose it is 1 will cancel. If you put x equals to 0, 0 power n is 0. Okay. So the total, that means this value is 0. Now minus or minus plus 1 by n into integral 0 to infinity e power minus x into x power n dx. Okay. So left hand side is gamma n equals to 1 by n into. Now rewriting that term, integral 0 to infinity e power minus x into x power n plus 1 minus 1. So this bar is nothing but bracket. Now comparing with equation 1. Right hand side integral 0 to infinity e power minus x Here x power n minus 1 dx. Here x power n plus 1 minus 1 dx. In place of n, you will get here n plus 1. So in place of n, this term is gamma n. In place of n plus 1, this term is 1 by n into gamma n plus 1. So left hand side is gamma n. Now rewriting the terms, finally you will get gamma n plus 1 equals to n into gamma n. Okay? I will repeat again the same proof. Gamma n plus 1 equals to n gamma n. By the definition of gamma function, gamma n equals to integral 0 to infinity e power minus x into x power n minus 1 dx. Now integrate using UV formula. UV formula is u into integral v minus integral u dash into integral v. Here u is e power minus x. Integral of x power n minus 1 dx is x power n minus 1 plus 1 by n minus 1 plus 1. Now 1 cancel. X power n by n. Now limit 0 to infinity minus integral 0 to infinity. Derivative of e power minus x is minus e power minus x. X power n minus 1. Integral value is already known, x power n by n. Now substituting the limits. If you put x equals to infinity, e power minus infinity is 0. Okay. If you put x equals to 0, 0. Okay, 0. Now minus or minus plus 1 by n into integral 0 to infinity e power minus x into x power n dx. Okay. Now rewriting that n can be written as n plus 1 minus 1, gamma n equals to 1 by n integral 0 to infinity e power minus x into x power n plus 1 minus 1 dx. Now comparing with 1 and 2, the right hand sides of 1 and 2, right hand sides of 1 integral 0 to infinity, integral 0 to infinity e power minus x, here by e power minus x power n minus 1 here x power n plus 1 minus 1. In place of n, you will get n plus 1 here, dx. So here n, that's why this definition is gamma n. Here n plus 1, this is gamma n plus 1. Now left hand side is gamma n equals to 1 by n into gamma n plus 1. Now by simplifying, gamma n plus 1 equals to n into gamma n. Okay. So today we are going to stop here. So in the next class we will discuss another property and remaining class. Thank you. Meet again. అది అవ్వలేదు కదా.